difference. The true single mode. Of course, you know that. We went through all this already, so you do know this. But your setup, of course.
So this is
the power, the Heaney power supply.
okay. So that's the Heaney,
and that's yours.
Okay.
Or will be yours.
Okay. Right. I saw one of these actually at Stony Brook.
Yeah,
with Eric Jones.
They had something like that.
Right.
Yeah. You were dealing with, was it Eric Jones? What's his name?
Eric Jones, who runs the laser lab there.
He took over after John No.
Right.
Who I used to work. I used to go there annually.
Right.
With John No and Hal Metcalf, and then when John passed away, I mean, it was actually before then when I kind of lost contact with them. I guess they weren't having that many students for a while, and so then Eric, contacted me a couple of weeks ago about this SFPI thing because he's trying to build one using Thor Labs mirrors, which would probably work for you, but this will be a lot more stable and solid than you want it to worry about.
Right. Good.
Dealing with it, but I'm going to actually try to build one. He found mirrors that I didn't even realize existed from Thor Labs. So I'm going to I'll build one up like that soon. And add some
so what is it? What is this specifically? This is a Mels Grill.
Yeah, this is Mels Grill.
RGB.
Yeah, it's supposed to be. I haven't tried blue. If you want, we can try blue, but it claims to do blue.
Maybe 488 or.
Well, probably at least 488. But just because it doesn't cut off sharply, it's going to go down to.
Okay, well, the three main wavelengths. Yeah, the main wavelength I'm going to be using is 532. Yeah. Because the whole purpose is for the Genesis.
Yeah.
Is that it?
Genesis. Yeah.
Genesis MX, right?
Yeah.
And then, at your suggestion, I'll try it with the 660.
Yeah, but if you're getting good holograms with it,
yeah, exactly.
If it ain't broke, don't worry about it.
No, exactly.
But those things do, after a while, you might find that it will need tweaking.
Right.
Some of those.
Right. And also and then I have the
blue.
488 Sapphire.
What's the blue? Sapphire. Yeah. And again, Sapphires are, unless it's a special one that's guaranteed single mode, they just work single mode, but not always.
Right.
There's something working.
Right. It has the newer, smaller
controller. Yeah, but that doesn't matter. It's really what's in that head that matters.
Right.
As I was saying, the Genesis, it's basically a Sapphire on steroids. So it's the same design.
Right. Oh, so this has a little cap. That's good.
Well, this cap actually has a hole in the middle, so you can kind of line up.
Okay, is that desirable? No.
Well, you don't necessarily need to leave the cap in, but you can line that beam so you know where the best response, the best resolution is going to be in the center.
Okay.
Unfortunately, it also means that back reflections will also go back to the laser at best when it's in the center. So,
gotcha.
I mean, I'll show you here.
Okay, I see you have it off a little bit off axis here.
It's a little off axis. If I adjust this so that beam goes right in, you see what happens.
Oh yeah. Oh, that's cool. So I'll have a
laser's not happy. Laser's not happy. It doesn't hurt it, but
so I'll have a way to see this now.
Yeah. Now, in fact, the way you're doing it, you're going to have a microscope slide or something sampling the beam. You're not going to be shooting the laser directly.
Right.
That's going to cut down by 90, 95, or 98%.
Right.
Any back reflections are going to be cut down by another 90, 95, 98%. So there's a lot less likelihood that it's going to affect the laser.
What a cute little variable beam splitter.
Well, it's a polarizer.
Oh, polarizer. Okay.
That's a polarizer, which would work in your case. Something like that would work as a attenuator because your beams are going to be all polarized. So I assume.
Right. May I touch it?
Can you touch it? Yeah, you can touch it.
I've never seen one like that.
Well, the polarizer, the disc is standard. I think that's Mels and Thor Labs. They all have similar things for exorbitantly high prices. You can get them for about $6 on eBay as a camera linear polarizer. It's the same thing. Right. In fact, for the camera, it might even be better because it has to be photographic quality. So they charge you $200. Get it for $6.
And there's your old guy.
That's the old guy. And that's I told Phil, I'm not giving up the nice gold colored mount. I want the gold colored.
Right. Well, you can get one of those for $76 on I think that's the Spectrophysics.
Yeah, Spectrophysics.
Yeah, they have one. But
who has one?
eBay.
Oh, eBay has. I might, we probably pick those up as a matter of course because you know, sell these things.
Right.
So this thing is fine. I got this. The controller's fine. The only thing I did is replace the LED.
So it says optical spectrum analyzer.
Well, it's actually the correct name is laser spectrum analyzer.
Okay.
Optical spectrum analyzer is something else. I don't know why whoever Mels did the silk screening didn't know.
Did you ever go see them when they?
What?
Did you ever actually go to Mels?
No, only at one trade show I saw them, right. And the guy I was dealing with was out sick or something. So.
Oh, okay. So these little guys right here, this little cable.
Okay, this is the high voltage cable.
Okay.
Ironically, the high voltage cable is a skinny cable.
Right.
But they did that specifically so you wouldn't accidentally plug it into the photodiode or something like that.
Right. So it goes in the side.
Yeah, it's the only way.
There's
only
one way
that.
Does it screw or plug?
It's just push.
Push. Okay.
Yeah. These are all standard. Are called BNCs.
Right.
And the only risk here is if you hook the output of the preamp to the input of here, that might damage the photodiode. But that's the only risk. You just make
so
sure you pay attention to the way they're labeled. It says input. It should say input.
Yeah, it does.
Yeah, it says input.
Yep.
Yeah.
Okay, so it comes around here.
And then this one is the trigger. This trigger for the scope, as we'll see in a minute. We'll put it here.
Okay.
You can use either this one or this one. That's blanking. This one you see is just a little spike.
Right. So it goes to on yours.
Or it goes mine. Mine happens to go to channel 2. Okay. Yours will probably go to the external input, trigger, but it doesn't much matter.
Yeah. Okay.
And that's just a little spike. You can see that trigger signals a little spike. The one called blanking, which is
is this single mode? No,
that's not single mode.
It's not a single mode laser.
That's why you see them coming.
So wait a minute, what are you doing now?
I'm just moving the trigger signal from trigger to blanking, and they're equivalent. I mean, as far as you're only going to use this for triggering the scope, you can use either one. It's this signal at the bottom.
You know what? You lost me.
The scope needs to be synchronized so that these things stay stable.
Right.
Yeah. I'm using right now the one called blanking.
Okay.
It's called blanking, which is this. It's actually.
So this says oscilloscope. Okay. So these are the out. These are the. Okay. All right.
Yeah. And
so the difference between blanking and trigger.
Trigger is a spike. It's just a short pulse.
Okay.
As you can. Let's do blanking first. Blanking says the active portion is, I don't know which one it actually considers to be the active portion. But if we do this, let's call that the active portion. Where it's low, it's the ramp, and the top is the retrace. And we're triggering on the high to low transition, so we get the actual display stable.
This is this display of the actual mode of the laser.
That's the actual modes of the laser. Because as it's warming up, they're drifting around. And if you were to use it to make a hologram, you would see bands in the hologram when you've got significant fraction of two of them present.
Gotcha. Okay.
Now, as I say, there's also this one.
So you can do this live while it's hot.
Yeah.
Hot switch.
Yeah, you can do this switch.
Okay.
And the trigger is just these little spiky things, but it's really the same signal. It's just, as far as you're concerned, it doesn't matter. The scope will trigger on either one of them.
Okay. So the one that I use, though, will be...
I'd say probably use the one called blanking.
Blanking,
It's easier to see what it is. This is
so let's see this.
Probably just put the through of a capacitors.
Where is that on here?
Well, it's going to be the external trigger. If you have a channel, probably channel 4, you'll probably use channel 4, and then you'll select that to be the trigger. But you're gonna do it. Actually, you're gonna do it in a minute. You're gonna hook this one up in a minute.
Okay.
So
gulp.
Gulp. Gulp.
Okay.
Yeah, we